Hello everyone, welcome to the course Inside Chinese Culture. We all know that China is now leading in some technological advances, such as high-speed trains, which have linked most big and small cities and popular tourist destinations. At a running speed of 350 kilometers per hour for G trains and a speed record of 480 kilometers per hour, passengers are able to fly on land. China is also the first nation to begin construction of magnetically levitated trains. While projects to build magnetically levitated trains have been cancelled in the West. Also, China moves ahead by leaps and bounds in 5G technology. Parts of China have 5G access right now, and a lot more are coming. Every Chinese is proud of what we have achieved technologically, and we have made contributions to the world's civilization since ancient times. The four great inventions, compass, gunpowder, paper making, and printing, changed the world. Without the importation from China of navigational improvements, such as compass, Columbus would not have sailed to America, and Europeans would not have established colonial empires. Without the importation from China of paper and printing, Europe would have continued for much longer to copy books by hand. Literacy would not have become so widespread. Actually, apart from the four great inventions, ancient China was technologically advanced in a variety of fields. According to Robert Temple, an expert in Oriental studies, possibly more than half of the basic inventions and discoveries that the modern world rests on come from China. In this unit, we will talk about ancient Chinese technology in terms of engineering, agriculture, and warfare, together with a comparison between East and West. In this session, we will first focus on engineering, including the two important inventions that contributed to our advance in iron casting: the double-acting piston bellow and blast furnace, as well as the chain pump. Ancient China was pretty advanced in iron casting, which contributed much to the development of engineering. Around 2,500 years ago, when people in Europe or the Middle East could melt an ounce of iron, ancient Chinese were casting multi-ton iron objects. The early success in iron casting was largely due to a superior form of bellows that delivered a continuous stream of air to a furnace instead of an interrupted stream, as from the bellows used in the West. Though a seemingly unimportant device, the Chinese bellows turned out to be a crucial technological development. Let's first look at the double-acting piston bellow. The double-acting piston bellow seems to have been widespread by the 4th century BC. The bellow expels air on the forward stroke and on the backward stroke. A piston is pushed in and pulled out of a rectangular box, which acts as a cylinder. Feathers or soft paper are wedged round the piston to make sure that it is airtight and lubricated in its passage. However, the Western bellows expels air only on the downstroke, so there was no air enhancing the fire about half of the time. The Chinese bellows had air enhancing the furnace fire continuously. This enabled the Chinese furnaces to reach temperatures hot enough to melt iron. The Iron Age is generally considered to have begun around 1700 to 1500 BC. The introduction of iron allowed mankind to develop tools that were stronger and superior to stone or bronze. These improved tools increased productivity. Now comes the blast furnace. By the end of the spring and autumn period, the Chinese developed the technology of the blast furnace. This allowed them to heat the ore above its melting point and produce cast iron. The manufacture of iron using a blast furnace to produce a molten metal greatly expanded production. The process could be continuous. The molten metal flowed from the reducing furnace, was then poured into molds and made into a variety of products. Then ancient Chinese developed methods for the manufacture of steel long before the Western world. The characteristics of iron alloys are related to the carbon content. Cast iron generally has a high carbon content, which makes it strong but brittle. Steel, which is an alloy of iron with a low carbon content, is strong and more durable. The use of steel in agricultural tools was introduced on a wide scale during the Tang Dynasty. This led to a further improvement in productivity. Under the Song Dynasty, the iron and steel industry reached a level that was spectacular compared to that in Europe. By 1078, North China was producing more than 114,000 tons of pig iron a year. In 1788, 700 years later, England's production of pig iron was around 50,000 tons. Then, the chain pump. Another invention of great utility is the square pallet chain pump. It has spread from China throughout the world. It consists of an endless circulating chain bearing square pallets which hold water, earth, or sand. Although the chain pump may have existed some centuries earlier, we can take the 1st century AD as its time of origin. Because the first written record of its existence was about 80 AD in Wang Cheng's book, Discourse Weighed in the Balance. This pump can hold enormous quantities of water from lower to higher levels. The optimum angle of the slope at which the chain of pallets can be laid out is about 24 degrees. So if the pallets were well fitted, water can be raised by a single pump to a height of 15 feet. The pumps were later adapted for use as conveyor of earth or sand rather than just water. They were thus the first conveyor belts. Then the pumps were used not only for irrigation and supply of drinking water, but also for civil engineering works and for draining all sorts of sites. The pumps were so spectacular in their results that visitors from neighboring lands eventually adopted them in their own countries. And the first European square pallet chain pumps, which were modeled directly on Chinese design, appeared in the 16th century. Okay, in this session, we've talked about 3 ancient Chinese technological inventions in engineering. We will have more in agriculture. See you then.